Now let's talk about the colors. The colors of the northern lights, primarily green, red, and purple, are caused by interactions between charged particles from the sun and Earth's magnetic field and atmosphere. Green, the most common color, is produced by collisions between electrons and oxygen molecules about 60 miles above Earth. Red auroras occur at higher altitudes around 200 miles due to interactions with high-altitude oxygen. Purple and pink hues result from a mix of nitrogen and oxygen molecules at varying altitudes, with blue and purple colors stemming from nitrogen molecules, blue appearing at lower altitudes and purple at higher altitudes. The exact colors and their intensity depend on the altitude, type of gas involved, and the energy and speed of the charged particles, which are influenced by the level of solar activity. Different atmospheric conditions, including the specific gases present and their altitude, also play a significant role in determining the aurora's colors. Currently, we are experiencing a period of heightened solar activity, which is leading to more frequent and intense auroras. This increase in solar activity can be attributed to the current phase of the solar cycle, which is nearing its maximum. The increased number of sunspots and solar flares during the solar maximum results in more significant and frequent ejections of solar wind and CMEs. In addition to the visual spectacle, auroras are sometimes accompanied by sounds. This aspect of the northern lights is less understood and is often met with skepticism. However, there is growing evidence and documentation supporting the existence of auroral sounds. People who have experienced auroral sounds describe them as faint, crackling noises similarly to rustling leaves, distant static, or the crackling of ice. These sounds are typically heard during periods of strong auroral activity and in very quiet environments. But what's behind these mysterious noises? Several theories attempt to explain the origin of auroral sounds. The one theory is connected to so-called electrophonic sounds. Some scientists suggest that the sounds are created by electromagnetic waves generated by the aurora, which then induce vibrations in objects near the ground, such as hair, glasses, or other conductive materials. Another hypothesis is that rapid changes in temperature caused by the auroral activity might produce sounds as materials on the Earth's surface expand and contract. Despite these theories, the exact mechanism behind auroral sounds remains a topic of ongoing research and debate. What are the best places to observe these lights? Observing the northern lights requires a combination of clear skies, low light pollution, and, ideally, high geomagnetic activity. While polar regions are prime locations, the recent increase in solar activity has expanded the visibility range. There are a few prime spots on Earth, which are known for beautiful light shows, mainly in northern countries such as Norway, Iceland, Finland, and Canada. So, if I don't live near these areas, will I never see aurora lights? The answer is no. Due to the heightened solar activity, several regions that normally do not experience frequent auroral displays. 1. Scotland and northern England. These areas are witnessing more frequent auroras, much to the delight of locals. Northern United States. States like Maine, Minnesota, and North Dakota are experiencing more frequent auroras. Central Europe. Countries such as Germany, Poland, and even parts of France and Belgium have reported sightings of the northern lights. But how do these phenomena affect our lives? Solar flares don't significantly affect us on Earth, because our atmosphere and magnetic field protect us from cosmic rays. While instruments can measure radiation reaching the ground, even during the strongest solar flares, levels remain low. However, there are concerns about the impact of solar flares on astronauts and aviation workers. Astronauts and those who spend a lot of time flying, like pilots and flight attendants, especially near the poles, are more exposed to harmful radiation. Research suggests they may have a higher risk of developing cancer. Pregnant women in these groups and their fetuses are also at particular risk. During a major space weather event in October 2003, an official warning highlighted that people traveling north and south of the 35th parallel were at risk of excessive radiation doses. On the other hand, technology doesn't fare as well. Satellites and space probes outside Earth's protective magnetic field are more prone to malfunctions during geomagnetic storms, as charged particles can damage their internal systems. This can lead to significant telecommunications and GPS outages. These storms can also increase the density of the upper atmosphere. For instance, last year, a geomagnetic storm caused SpaceX to lose 40 satellites. In extreme cases, Earth-based power grids and other electrical devices can malfunction, highlighting the vulnerability of our modern infrastructure, despite all our technological advances. Join us next time as we delve deeper into the mysteries of our past and explore the possibilities of our future.